We're going to finish off with some Dunder methods today and a few other items from Python Basics. I want to do 2 Dunder methods. I want to make sure to get the add correct, and then I want to get the whatever this matrix multiplication Dunder method is. If we can get those 2, I'll be very happy. I know Dunder methods are actually pretty straightforward for the most part, even though they're weird looking. They're weird looking. So you guys, equals QQ. So we're going to make a new QQ, and then we're going to set this concat QQ dot name here. Here we go. We're gonna make it happen equals to self.name plus other.name, and then we're gonna say return concat QQ underscore new. Oh, I think I know what's going on. I think what the problem was, these things were doing some overriding. That's what the problem was. They were overriding. They were overriding my things, and they were making maybe. Why do sometimes use underscore before and after names? I'm a third year CS student. Hey, Yannick, if you're still here, I've got your answer. It's because they just decided it. There's no good reason. In fact, it is my least favorite thing about Python. Why? What? Why? They could have just done this. There's literally the software engineer who built this, right? Who made Python just decided to have double underscores on either side of the words that are reserved. There's no good reason for it, right? These 4 underscores are just obnoxious. Now, I don't like it. That's like the least, it's also like the most worst thing about Python, in my opinion. It's the most worst thing. So, have you seen Tim Berners-Lee, or the other legend in computer science universe? I've heard, yep. I know of Tim. Hey, Goku, I know of Tim Berners-Lee. I've not met Tim Berners-Lee. Been around long enough to know about Tim Berners-Lee. I'm so confused with those underscores. Me too. It's just something you just have to deal with it. One language has to have that one thing that's the least entertaining thing in the language. It just happens to be the undumb underscores. The interesting part is, though, they're very powerful. They're really powerful. Because you can do things like this. You can create a class, and then you can overload operators, right? You can overload operators. And the next one I want to overload is the matrix multiplication operator. That's what we're going to do. Thanks. I'm very excited about some Dunder methods. All right, so there is one Dunder method I really want to do. This one right here. This one. I want to do this one right here. This one. How do we do that? I want to use the @ symbol, the matrix multiplication symbol, essentially. The thing I want to do really badly is I want the Dunder method for matrix multiplication in Python. There we go. That's what I'm looking for. Dunder method. I want this. Okay, so it's called matmul. All right, I think I should be able to figure this out. Self and other. Perfect. All right, let's do it. Let's do the matmul. This is the one I wanted to do. This is the ultimate one right here. I just really wanted to do this. All right, so I think if we do new, hold on. I think we could say return self. Can we do that? Is that still going to cause a problem? Python magic. There we go. Let's see. Python magic. Hey, souls. Thank you for subscribing. Welcome in and happy Friday. We're going to hang out today and do some Python. All right, perfect. All right, let's see here. Where's that at? Here we go. Delete that. We were doing some coding there. Okay, so that still causes a problem. Apparently, this new is a problem. We're doing Dunder methods. We just added the matmul, and I really want to do this. I really want to do a matmul. I've been wanting to do this since it was quantified. Quantum told me about it. I've been wanting to do this. So here we go. Let's try it. Let's get our matrix multiplication. I want to do this. Real quick. So where's our matmul at? Well, here we go. I want to do this here. Let's do this here. All right, so I can see everything. Okay, so we're going to have a new array. We need to transpose, right? So for I in, so I will do this x in, self.matrix. Self.matrix. We'll make it like this. And then we'll say for y in self dot, oh, no, x, for y in x. Perfect, okay. So we need to access the elements of the matrix of other and self. Self.matrix is going to be x and y, right? This, y, right? And then we need to also grab other. But other is inverted. Actually, is it self? Self is inverted. I suppose self is inverted. So it needs to do, you need to do it like this. However, because of, we need to transpose it. Since it's equal, this will only work because of the dimensions. This is the transposition. So then you say, I believe you multiply, and then you say, so new. So we have a new matrix. So we'll say new QQ equals QQ, like that. Let's see real quick. All right, sorry guys, missing the chat messages. I'm really excited to do the matrix multiplication on my own. First time I always use NumPy, so I think it's really cool. For row and matrix, for colon. Oh, row and colon. Yeah, we could do that as well. Row and col. All right, I like that. I like that. Row, col, and then you have to do col row, col, col, and then row, like that. We got to 10,000. I just remembered it was really neat. I saw people using for_n(x). That looks hella confusing. For_n. Because it's, you think need to use enumerate to access the index. Otherwise, you're using the values of the list access. Is it? Oh, wait. So for, is it? Or, oh, wait. Are you sure? Wait, we should double check. Print row. I think you might be right. Or this is not the index? It's not the index? Are you sure? Are you sure that's not the index? So let's see. Print col. I'll do this. Print col. All right. See here. Col. We'll find out. We'll find out. Okay. Magic. All right. Var name dim. All right. Yeah, because that's not Visual Basic. Okay. So at oh, 1 second. Whoops. All right, let's rerun that. Okay. At col row. Okay. You might be right. List indices must be integers or slices, not lists. Okay. You're right. You were right. You were absolutely right. We got to use enumerate. Thank you. Return self child. We could do that. All right. So where do this? Say return self dot children. I could say return self children. To make it a little bit nicer. I see you there. Child. Oh, wait. Child. Oh, I see what you're doing there. Okay. I see what you're doing there. Okay. We could do that. Append child. So you're saying child equals child, basically. Basically straight up child right there. Like that. Just like that, you guys. And then return the child. All right. So this will give you access to essentially give an has-a. So you can add another element or another class into your existing class.